Hi, I'm Kelly.
Hi, I'm Alex.
We're from Signature Solar, and today we're going to show you how to install and commission the Growatt Inverter with these new LG high voltage batteries for an ESS system for your home.
So today we're going to be using the Growatt SYN. We're going to be using their 11.4 kilowatt hybrid high voltage inverter, as well as the LG high voltage 16H batteries. Now, we've already pre-configured a majority of the system by installing and mounting the batteries, as well as the inverter and the SYN. We've already gone ahead and installed our conduit and our cable tray here, so we've already done a majority of the work, and in this video we're going to go over the final steps of commissioning, going through wiring, communication setup, as well as programming. To get started, we're going to connect the MIN 11.4 to our SYN. We have 4 hex heads here that we're going to remove to access the terminal housing for the MIN 11.4. With our 4 screws removed, we have our terminal housing here. Now, these conductors run to our batteries, and this little antenna wire here will connect to our Wi-Fi. But we want to make sure that we are not powering any of our equipment yet. We want to make sure that no power from our batteries or from our grid is entering the system. We want to make sure everything's safe to operate. These conductors already run to our battery, but they are not connected just yet. So our next step that we're going to do, we're going to connect the 11.4 to the SYN with our line, neutral, and line 2 conductors. So next we're going to open up our SYN, and this has the same hex screws that our 11.4 does, except we only have 3 of them here. All right. So now with the front door open, we have our covers. These will require some Phillips head screws, and then we'll remove these keeper pins as well. So to remove these pins, we're just going to pull back, and there's this little flange down at the bottom that we're just going to put pressure on while pulling this top up, and then it just comes out. We remove the 2 Phillips head screws on the bottom, and this bottom bracket just comes off like that, or this bottom faceplate. To take the top off, we just need to remove the additional 3 Phillips screws, and we'll have access to the full internal housing of the SYN. Now, it's not necessarily required to remove the top cover, but if you would like to see all the internal circuitry, you're more than welcome to. For this video, we are going to open up everything. So as you can see, this is the full internal housing of the SYN. Again, you don't have to remove the top cover. Once you remove the bottom cover, all of the terminals that you'll need to connect to the SYN are available. This is what the SYN looks like with both of the face covers off. We're going to run our conductors. For the 11.4 to the SYN, we're using 6-gauge conductors. And we're just going to feed that through this back conduit here. So now we're stripping our conductors or our wires, and we are going to put ferrules. And if you have a crimping tool set, then this will work out just perfectly for you. Just go ahead and strip our conductors to the right length, and we'll just attach our ferrule on the end here, and then we'll crimp it. Just like that. Now that's going to allow us to get a secure connection inside this terminal block. Highly recommended that you get a ferrule set to ensure that all these strands stay connected when entering the terminal block. So here we're just going to connect our ferrule, take our crimper, make sure that all those wires stay nice and connected. Now that we have all of our conductors or our wires ferruled, we're going to insert them into the terminal block here. Now, something to note with this terminal block is there are no screws, there's no fasteners that you have to use any additional tools for. All we'll do is we'll push our wire into the terminal block here, and the jaws will bite down as we insert the conductors. So we have our line 1, our neutral, and our line 2. Something to keep in mind also is that we are not going through our backup loads when we're operating with the SYN. We will operate out of the grid terminal blocks here. And that's due to, 1, backfeeding electricity to the grid for grid sellback, but additionally, the SYN will act as the anti-islanding mode and the disconnect from the grid itself. As you run your conductors, keep in mind to color code them as you go along to ensure that all the conductors are going to the same spot and none of them are overlapping. And what I mean by that is we don't want to get any of our hot conductors mixed up with our neutral or our ground conductors. So a simple color coding is our L1 is just the straight black jacket, our L2 is going to be red, our green is going to be ground, and our neutral is going to be white. First, we'll connect our grounding conductor. The ferrule is going to make all of those strands stay nice and connected together. We don't want any loose strands not making full contact within the terminal itself. So for our grounding terminal block here, we're just going to use a Phillips head screwdriver and ensure that it is fastened tightly. Now, it's always recommended to torque these to specs, and also to do a pull test is what I like to do to make sure that it has a nice secure contact with whatever it's connected to. So ground's not going anywhere. So next we're going to connect our hot conductors, our leg 1, neutral, and leg 2. At the bottom right under the terminal block, you'll see the backup and grid connections. Again, when we're operating with the SYN, we want to use the grid connections. So I'll take the black conductor and I will connect it to the L1 terminal block. Now, again, do a quick pull test, ensure that it doesn't have any loose connections or that it's not going to come out of place. So we have our L1, we'll connect our neutral, and again, all I'm doing is I'm just pushing them with a mild amount of force, and the teeth at the back of the terminal block are biting into the ferrule itself. This is all of our conductors that's going to supply power to the SYN connected, and again, this is connected inside the terminal housing. We're now looking inside the SYN's terminal housing. This breaker right here is what we'll use to connect the output leads from our inverter. This neutral will not go to the neutral bus up here. It will actually go to a neutral bar down here, which will connect to this electricity meter. So now that we've connected all of our conductors, we have our 2 hot legs, L1 and L2, into our breaker. We have our neutral feeding to the neutral bar that will connect to this electricity meter, and our ground is connected as well. For this install, we'll be using a smaller backup load panel, or our critical loads panel, and this will actually connect directly to the SYN, which we will wire up next. Now, if you're doing whole home backup, what you'll most likely have is a larger main load panel that is rated for 200 amps, which the SYN can fully support. We've pulled our conductors from our load panel to the SYN. Again, if you're going to have a larger backup panel, then you'll need larger conductors. But for us, we're just going to be using a 60 amp breaker, and we have our 6-gauge wire here. We'll connect our neutral, our ground, and then our 2 hot conductors from the SYN terminals here to our load panel. So now we're setting up communications between the MIN 11.4 hybrid inverter and the Growatt SYN. For this connection, we'll be utilizing a standard Cat5 or Cat6 Ethernet cable. And what we'll be doing here is we'll be taking the green wire and the blue wire to set up communications. So we'll show you how to do that right now. Now that we have our blue and green conductors from our Cat5 or Cat6 Ethernet cable, we will be using the 3-pin connector that comes with the Growatt 11.4 inverter, and this will connect over here on the communications board. Setting up our communication cable with our 3-pin connector. Now this 3-pin connector comes with the Growatt 11.4 and all the Growatt inverters. What we'll do here is we'll take our Cat5 or Cat6 cable. We have our blue and our green conductors. Our blue will go to B and our green will go to A. To connect the communication cables to the terminal block, we will use a small flathead screwdriver to secure our 2 communication cables. So as we can see here, our blue communication cable, our blue conductor, communicates with B, and our green communicates with A. So next what we'll do is we'll take the 3-pin terminal block and connect it to the 3-pin port on our communications board. Next we are in the SYN. So this is going to be setting up the communication within the SYN. We have a 6-pin terminal block here. Again, we have a blue and a green wire. These actually connect to the Growatt 11.4. The blue and the green will go into the 2 in the middle, where blue is on top and green is on bottom. So something as shown here, where we're using the 2 in the middle of our 6-pin connector, and the blue is on top and the green is on bottom. With our blue and green communication cables connected to the 6-pin terminal block, we're now going to take the 6-pin terminal block and connect it to the top 6-pin connector within the SYN. Now that we've set up communications between the SYN and the 11.4, we're going to move on to setting up communications between the LG Prime batteries and the 11.4 inverter. For communications between the LG Prime batteries and the Growatt 11.4 inverter, we'll use another standard Cat5 or Cat6 Ethernet cable. For this install, we will be using orange, orange-white, brown, and brown-white. Blue and blue-white, green and green-white can be removed. So with these conductors, we are actually going to connect ferrules to them to ensure that we get a proper connection with the terminal block and the communication block with the LG Prime battery. So I'm just using some very small ferrules here and making sure that they are biting on properly to the cable. If you have any excess cable sticking out of your ferrule, you can just take some wire cutters and clip it away to the top of the ferrule like that and make everything nice and clean. So now that we have our 4 communication cables, our 4 conductors ferruled, we're going to connect to the inverter comms ports on the LG Prime. So we're going to take our orange conductor, we're going to connect to enable 12 volt. We'll take our orange-white to enable ground or enable GND. Our brown will go to RS485A+, and our brown-white will go to RS485B-. When you go to connect these communication cables or our ferruled ends into the terminal housing or the inverter comms ports, you'll notice that there are 2 holes, one on top and one on bottom. The circular hole is where the cable or the ferrule will go, and we can take a flat end, a very small flat end screwdriver, insert it into the bottom square hole, and what that's going to do is open up the jaws at the back of the inverter comms port to allow us to insert the communication cable easily. So now it's essential as you go along and insert these communication cables into each port to give them a slight tug to ensure that the jaws at the back are actually biting into the cable or the ferruled end. It's going to make sure that you're getting communication across the wires. So now we have our communication cables set up to the inverter comms port. Next, we'll move on to the secondary battery. But before we move on, we're going to adjust the dip switches for our primary battery. On the left, we have 2 dip switches, and this is going to be our comms resistor dip switches. And on the right is going to be our battery identifier dip switches. When we're setting up our batteries for communication, our primary battery should be the battery furthest from the inverter. For that, we will ensure that our comms resistor is down or in the on position, and the dip switches on the right or our battery identifier are in the up position, as you can see here. So both dip switches on the left are down, and both dip switches on the right are up. An important note to make when adjusting the dip switches is if you're experiencing any communication issues, the reason for that may be due to the oil that reduces the amount of wear and tear on the dip switches, getting in between the contacts of the actual dip switches and the relay. So if you're experiencing any communication issues, you can move the dip switches up and down 20 or 15 times to remove the oil and ensure that the relays and the contacts are making a good connection. We're at our secondary battery now. Again, we'll adjust the dip switches, but for now, we'll want to set up the communication cables as we did with the primary battery. We'll use orange, orange-white, brown, and brown-white as our 4 conductors. Again, we'll set them up the exact same way using the same inverter comms ports as we did with the primary battery. The only difference is we are routing our primary battery cable that we just wired to the secondary battery. And we are taking our secondary battery communication cable, and this cable right here will run and set up communications between the Growatt 11.4 inverter and the LG Prime battery stack that we just created. When we're setting up communications within the secondary battery, highly recommend that you use ferrule connections, especially when we're talking about double landing within this inverter comms port here. So I'm going to use ferrule connections to ensure that the continuity and the communication signal between the 2 wires is secure. We now have our 2 communication cables paralleled together with the ferrule connections. And again, we'll use orange for enable 12 volt, orange-white for enable ground or enable GND, brown for RS485A+, and brown white for RS485B-. All of our communication cables are connected to our inverter comms ports. We'll give them a slight tug just to ensure that there's good continuity there and that the jaws or the teeth in the communication port are holding onto the cables tightly. For the dip switches in our secondary battery, we again have our comms resistor dip switches and our battery identifier dip switches. For the secondary battery, our comms resistor dip switches are going to be in the up position or off. Our battery identifier dip switches are going to be up for the left and down for the right. So both up on the comms resistor dip switch and on the battery identifier dip switch in the secondary bat position, up on the left and down on the right. For the secondary battery, our secondary battery is actually going to have the communication cable that communicates with the 11.4 Growatt inverter. So our primary battery is paralleled with the inverter to battery communications port within the secondary battery here. Now, to finalize communications between the LG Prime battery and the Growatt 11.4 inverter, we're going to use a standard RJ45 connector, and this is pinned out to T568B, which if you look up that pinout and you want to make your own RJ45 connection, that pinout is going to be for pin 1, orange-white, pin 2, orange, pin 7, brown-white, and pin 8, brown. But if you're wanting to buy a RJ45 connector that's pre-made, the T568B connector or pinout is going to be the most common on the market. The RJ45 connector will just plug into the Ethernet port on the communications board for the Growatt 11.4 inverter. When working with communication cables or when running communication cables through wire troughs, cable trays, or any conduit, if they're running in the same cable tray or conduit as hot conductors or high voltage cables, you'll need to make sure that the insulation of the communication cable is the same rating of the insulation of the hot conductors or the high voltage conductors that you're using. For this instance, we are just using standard Ethernet cable, but for code compliant installs, you'll need to make sure that that insulation rating is the same insulation rating as the hot conductors, which is typically around 600 volts. Something else to consider with communication cable is interference, especially with high voltage conductors like we have with the LG Prime batteries or PV conductors. Our communication cable will need to be shielded to limit the amount of interference from those high voltage conductors with our communication. For our installation and our setup, we are paralleling our communication cables from our primary battery and our inverter to battery communication cable within the secondary battery. Something else that you can do is actually splice into and parallel the communication cables in your wire trough or your combiner box with a standard Wago connector. With our communication setup now, we will go ahead and wire up our battery wires here. So I'm just going to go ahead and move these communication cables out of the way. We'll strip and ferrule each of our battery conductors and get them connected to our battery positive and negative terminals. Something to mention with the 11.4 and other Growatt systems is that we have 2 terminal blocks for our batteries, so we don't have to go to any kind of combiner box. We can take each output from our battery and go directly to the inverter. So we'll take our primary and secondary battery and connect it to the top and bottom battery positive and negative terminal blocks here. Here we have all of our battery conductors or all of our battery cables ferruled. Now, remember, these are not connected to the battery currently. These are not live conductors. We're going to make sure that we connect our power sources like our battery and our grid and our PV at the very end. Next, we'll connect these battery conductors, these battery power cables, to our terminal block. This is very similar to how they were connected on the connection points or our output from the 11.4 Growatt inverter. Just insert them into the terminal port here and just push in firmly. Once you push in firmly, the jaws or the teeth in the back of the port will grab the conductor. Just give it a slight tug to ensure that it's seated properly. With our battery cables connected, we're going to reattach our communication cables here. Like so. We're going to walk through just a few more components that you can install with the 11.4 inverter before we actually connect our power sources. One is going to be our rapid shutdown button, or our rapid shutdown initiator, and this is actually going to connect to the 3-pin connector here, and this is a normally closed circuit or a keep alive signal that will actually be wiring up through the rapid shutdown. The 11.4 also has its own built-in RS initiator, a rapid shutdown initiator, and that's on the bottom, and it's just a little switch that you turn. Once the switch is initiated, our AP Smart or our Tigo transmitter will send the signal to our optimizers or our MLPEs on the roof and essentially stop power from the array coming down the line, but it will also disconnect the PV power directly at the inverter. To set up an external rapid shutdown transmitter, we are going to remove this 3-pin connection right here on the side of the comms board. And this already has a little wire that connects our far left and our far right terminals. Again, this is signaling to me and to us that this is going to be a normally closed circuit. So when you're going to set up your rapid shutdown button, you'll need to use the normally closed circuit terminal to ensure that during normal operations, the inverter stays operational. Here I'm just opening up the RSD initiator switch, so that way we can connect our communication wire to it. Now the communication wire will flow through this switch and back to the 11.4 inverter, specifically the 3-pin connector that we just disconnected. Now there are many kinds of RS initiators on the market, but this one is just a standard RS initiator that has a normally closed circuit. To wire up the rapid shutdown initiator that comes with the Growatt 11.4, there's just 2 inputs. One is going to be for our blue wire, and the other is going to be for our orange wire. Now, when we go to connect to the 3-pin connector, we're going to connect the orange and blue wire the exact same way. All that we're doing is making sure that the circuit stays closed and that we have continuity across both conductors to keep the keep alive signal there. Once we initiate rapid shutdown, so we push our emergency stop button here, what we're doing is we're actually opening the circuit and no longer allowing the keep alive signal to flow between the 2 wires. Grabbing our 3-pin connector, we're just going to remove this jumper wire between the 2 terminals. So we'll take a small flathead screwdriver, similar to what we used with the communications between the 11.4 and the SYN. And all we're doing is we're removing that jumper cable, and we're going to grab the communication wire, the blue and the orange, and connect them to the 2 terminals here. Again, it's not necessary which wires go where, as long as our orange and our blue go into either or of the 2 terminals to have the keep alive signal there. So for me, what we're setting up is our blue is on the left and our orange is on the right, and that should be just fine. All we have to do now is connect it back to our communication boards here, but before we do that, I want to talk about the wire that we're using for the rapid shutdown. For this test and this commissioning video, we are using just a standard Cat5 or Cat6 Ethernet cable, but keep in mind, depending on the environment that you're running your communication cable through is going to determine the wire type that you actually need for this communication setup. For us, again, standard Cat5 or Cat6 will work, but for you, that may differ. So ensure that you're working with your local installers to make sure you have the correct wire type to carry this signal. A noteworthy mention is the Darkstart feature that Growatt offers. Here is their Darkstart button, which I will show you how to wire up here shortly. The Darkstart feature is essential for multi-day grid outages, especially when the batteries are depleted throughout the day and the inverter's having a hard time waking up in the morning. All you have to do is click the button, which is going to enable the inverter to start using the PV power that it sees in the morning to charge the batteries when they're completely dead. The model that we have here today has a knockout on the back with an end cap pre-installed. So all we'll have to do is remove the end cap. And here we have our Darkstart button with the lock nut, which we will just unscrew. And we will feed our 2-wire connection through the back here. And as you can see, this is not a fully circular hole. We have rounded corners on the side and we have 2 flat faces. And the Darkstart button will fit in there according to that. Next, we'll take our lock nut and place it back on the Darkstart button. Next, we have our 2-wire connection, and this will connect to this 2-wire pin up here at the top of our communications board. During the installation, I disconnected this Wi-Fi antenna connector. Now, the reason for that was just to make the install a little bit easier. So what we're going to do is we're going to reconnect that. So it should be pre-installed whenever you take the inverter out of the box. Again, I just removed it to make the install a little bit easier of the wires. One thing you will have to connect to set up communication between your Wi-Fi router and the Growatt 11.4 is this Wi-Fi antenna. And the Wi-Fi antenna will connect to the bottom of the unit, right where we see this cable going here. All it is just a screw-on connection. With the Wi-Fi antenna now in place, we can set up communications with our Wi-Fi network. If you don't have Wi-Fi on the installation site, Growatt offers a cellular kit that provides a 4G antenna with a new communications board, so that way you can use a cellular network rather than Wi-Fi. With the 4G cellular kit that Growatt offers, that comes with a 5-year communication plan. We are now at the step of connecting our battery conductors, our positive, negative, and ground, to the battery itself. Remember to make sure that the breakers are in the open or off position. We don't want to connect any live conductors, and we don't want to turn on the system just yet. Again, we're going to use ferrules for our connections, and similar to the connection with Growatt, we're going to push into the connection ports here, and the jaws or the teeth are going to bite into the ferrules, and we'll give them a light tug to make sure that they don't go anywhere. With our conductors ferruled, we'll go ahead and insert them into the terminal block here. We'll take our red, connect it to positive. Again, we're just pushing in, and giving it a light pull to make sure that the teeth on the back bite into the ferrule. We'll take our ground and connect it to G and D, or ground. And our negative. We'll repeat the same steps for the primary battery that we did with the secondary. We will remove the insulation, insert our ferrules, and insert them into the terminal block here. With the LG packaging, we also get these neat little zip ties that have this point on the tip here. And this point will actually clip to the base plate inside the battery. And this is a great option for keeping your hot conductors or your positive and negative conductors separate from your communication cable. One of the final steps in commissioning and installing the SYN is going to be connecting our grid conductors. The SYN is rated for service entrance capabilities, which means that you can connect your meter directly to the SYN, but you'll always need to contact your local AHJ or authority having jurisdiction to ensure that this setup is proper for their rules and regulations. When connecting the grid to the SYN, it's important to know what kind of service you have. The most common services that you'll find are 200 amps, which is what the SYN is rated for. As you can see here, it has a 200 amp main breaker, which is the reason that you can have it be your main service entrance, which is when you connect your meter directly to the SYN. For that, if you're running a 200 amp service, you can use the SYN with its 200 amp breaker. Just know that you'll need 3/0 wire, copper 3/0 wire to make that service entrance connection. Included with the SYN packaging, we have a breaker lockout kit. Now, this is going to be manually installed by us, and what we'll do is we'll take the single screw that comes with it and we'll actually secure it to the breaker itself. This is essential for lockout tagout procedures where you need to ensure that the main service feed does not get powered on without your permission. To install the breaker lockout kit, there is a small green cross that we will take the included screw and secure the lockout kit by inserting the screw on the cross itself. So I'm going to go ahead and get the pilot hole started. As you can see, there's a screw hole right behind the cover here. And we will take our lockout kit. And insert it like so. This kit is going to ensure that we can put a lock and prevent the breaker from being turned on. Next, we're going to wire up our grid conductors to the SYN. Now, we have a 100 amp service coming in. And our conductors are going to be slightly smaller than your standard 200 amp conductors that you would see if you were doing whole home backup. We're going to wire our hot legs to the breaker input here where it says grid, L1 and L2, and our neutral and our grounds will go at the bottom here. We now have the SYN wired up to the grid connections here. If at any point you feel uncomfortable with the install or feel like you don't really know where to go, always recommend to contact a licensed electrician or installer to help you commission the system. We are working with electricity, and if you do happen to be backfeeding to the grid, you'll need to go through all the approvals and permit processes anyway, so have the electrician wire up your grid connections in the SYN. Very simple, just our 2 hot conductors, our neutral, and our ground. Very similar to how we would wire up a main load panel or a 200 amp breaker box. Next process in this commissioning setup, we are going to turn on our batteries and supply power to the inverter and the SYN. We'll commission everything through the Growatt app, and then we'll power on the system fully, supplying power from the grid and powering a few loads. As a safety precaution and something that I like to do before I power on any circuits, I like to do a continuity or an ohms test to make sure that I'm not getting any cross polarity across the battery terminals, and to make sure that my positives on my battery is making good contact with the positive terminals on the inverter. So with that, we'll just switch our multimeter to our ohm or continuity reading. We'll make sure that we're getting a good signal, and then we'll do our continuity test between the battery and the inverter. One probe will go to the inverter. We can use a little square terminal right above the positive input. And all we're doing is we're just touching that back terminal there. We'll take our red probe here and touch it on the bottom square hole on the battery. And as we can hear, we're getting continuity between our 2 positive connection points from our LG Prime battery to our Growatt inverter. And next, just to make sure that we're not getting any solid continuity between positive and negative of our battery terminals, we'll do the same test just on the positive and negative inputs. So I'm connecting the red probe to my negative terminal on my battery and the black probe to the positive terminal on my battery, and I shouldn't hear any beeps or get any continuity. Now, if we start to see ohms or we start to see numbers flash on our screen here, that's okay. Most likely what's going on inside the system is that the positive and negatives are seeing each other because they are charging capacitors within the internal circuitry. If you're getting a continuous beep and we see 0 ohms across our multimeter, then there is a short somewhere and we need to identify that. But for right now, it looks like we are not seeing any continuity between positive and negative, which is a great sign. After performing our continuity test, we ensured that there is no cross polarity happening between positive and negative. So at this time, I'm going to go ahead and power on the batteries. And to do that, there's a breaker at the back that you just put in the closed position. I'll do that for both batteries, but as you can see, our LED indicators here light up. So as we can see with the batteries powered on now, we have a solid green LED on both of them. If for any reason you have to walk away from the installation during the commissioning process and you come back, make sure that you still have a solid green light. If the green light is pulsing slowly, where it's on and then off, on and off, then they're in standby mode and we'll need to power cycle the batteries to wake them back up. To do that, we'll just turn the batteries off. We'll make sure that the LED lights turn off completely, and then once they're turned off completely, we can power the batteries back up and that will complete the cycle. We now have our grid connected to the SYN here. We're feeding directly to the 200 amp main breaker there. Now, if you're doing whole home backup and you're feeding a load panel, you'll need to know what kind of service you have. The SYN is rated for a 200 amp service, and that is what it is listed for. So if you're running 200 amps, you'll need significantly larger cables than what we have here, most likely 3/0 copper wire. For us, we have a 90 amp service, so we're using significantly smaller cables than what we would use for a 200 amp service, but that is something to keep in mind when you're determining what loads you're wanting to power and the service that you have for your house. Additionally, Whenever you're doing backfeeding or you are selling power back to the grid, you'll need to go through all the permitting and process as well. So contacting a licensed electrician or an installer to wire the grid connection from the SYN to your meter or your disconnect is highly recommended and will most likely be required when you're doing some type of service agreement with a utility company. If at any point you felt uncomfortable or you feel uncomfortable installing these wires, we always recommend to contact a licensed electrician as we are working with electricity here. With all of our cables run, we'll next perform a continuity check to ensure there's no cross polarity between our conductors. After that, we'll power on the batteries and then the grid to ensure there's plenty of power to commission the rest of the system. With grid power now supplied to the SYN, we will turn on the 200 amp main breaker here. Not sure if you can hear it, but there are relays that clicked on. Our electricity meter is now indicating that there's power. And this breaker right here will supply grid power to our inverter. With the inverter now receiving grid and battery power, the next step is to connect the Wi-Fi antenna to our local network. Then we can go on and commission the system. With our Growatt 11.4 and our SYN receiving power and they're turned on, we're going to go ahead and start the mobile app and computer commissioning process. One of the first things that we're going to do is go to the OSS/Growatt. And if you go to Google, which is what you'll see here on our screen, you'll just type OSS-Growatt and you'll click the first link that populates there. From here, we will go to United States and Canada or whatever region you're in. You will click the register button in the top right. Select the installer count and click next step. From here, we'll follow the steps. We'll select the country. You can just type it in if you'd like. United States. The inverter serial number that we'll be operating with, and that inverter serial number will be found on the left-hand side of the unit. Where the company name field is, we will just enter our name. We'll enter the address of where we are installing this device. And the company website, we do not have to enter. We'll click with the agree with the company's terms and click register. So once we register our account, we will just enter the data fields here in the improved personal information. I've gone ahead and entered all of my information in. We have the company name, which will be your name. You'll create your password, your real name, your email address. The email address you have here, you'll want to click a get verification code where it says verification code and then just enter that verification code in once it's sent to your email. Once all the data is plugged in, we'll just click yes. And right here we have a success window. After we enter all of our information, we will have full access to the OSS portal, from where we can go to create our plant and our end user account. Now that we are on the OSS portal, we will go to the top left here where it says monitor and we'll create our plant list and an end user account. Now the end user account is what you will use most of the time to monitor the system. For plant list, that is the actual plant that we will create for the system that we just installed. So first we'll go to end user and we will create new user. From here we will enter an account name, the password, and the email and phone number. But for now, all we have to do is enter the account name and the password as well as the country. Alright, now we have a pop-up window that says it was successful. So under our account we have a new install as well as the end user account that we just created. Next, we'll go to the plant list button on the top left, and we will click the add plant button. From here, we'll enter the plant name, the amount of solar panels we have, the installer, so on and so forth. So please go ahead and plug in the data that you have for your installation site. Now that we've entered all of the information into the required fields, something that I want to point out is where it says assigned user. This will be the user or the end user that we just created a few minutes ago. Your plant type will be residential, and you will enter your additional information like country and city. Once you have all the required information in there, you'll just click yes at the very bottom. And we can see that it was successful. Now that we've created our plant and our end user account, we'll move to our mobile device and we'll use the ShineTools app that can be found in the Google Play Store or the Apple Store on your phone. So on the iPhone here, we'll use the ShineTools app, which is found in the top right corner of the screen you're seeing. Once we open the ShineTools app, we'll go to the O&M user account where we'll enter our account information that we just plugged in on the OSS portal. If you're curious what your OSS account name is, you can go to the OSS portal under the User Center. Where it says User and Information, you can click the account. Once we're logged in, we'll see the main screen here. And in the top right corner, we will click the 3 horizontal bars. And from there, we'll click the Quick Site Setup. Now, this is step number 1, where we will add the end user account that we just created on the OSS portal. Click Next. The plant is, again, the plant that we just created within the OSS portal. And from here, we'll click Add the Device. And we will scan the barcode on the left-hand side of the unit here. All right, and now that it's scanned, we'll just hit the Yes button. And we see that we get an icon that says it was successful. So we'll click Next. And from here, it will find the Growatt Wi-Fi signal, which we will connect to. Click Join. And we'll click Done. So step number 4 is upgrade equipment. Here we can see our current version and our target version. We will click the Next button. Next is the network config setting. And here we will enter our home Wi-Fi and password. So we will select Wi-Fi here. If you get this pop-up, just click Keep Trying Wi-Fi. And here we will enter the Wi-Fi name manually. Once we've entered the SSID and the Wi-Fi password, which will be the Wi-Fi name, we will click the Connect to Network. Now that we have our Wi-Fi set up with the Growatt 11.4 inverter, we'll move to step 6, which is going to be setting the basic parameters. The first thing that we'll want to do, especially when working with the LG Prime batteries, is go to Battery Type and selecting LG Battery. Once we've done that, we can just click the Confirm button. Now, right under Battery Type, you'll see Grid Code. Now, where we're located, we'll use IEEE 1547, but this grid code depends on the region that you're in, so it may be different for California or Hawaii. We see that our output mode is set to split phase, and our voltage level is set to 240. Now, there are some other settings on here, like pre, PTO, and EMS, and if we hover over or if we click the Information button, we can see some more information there. Next, we'll click the Next button. And step number 7 is installation information. So here it's loading the data. We can see the plant, the equipment that we're using, which is the 11.4, its serial number, the data logger, its status, which is currently in standby mode, our grid code, and voltage levels. And as you can see here where it says battery type, battery 1 serial number, and battery 2 serial number, we're getting communication with the LG batteries. And once everything looks fine, we'll click Preview. We can go through that once more, make sure we have everything set accordingly, and we'll say Finish and Screenshot. We'll say Quick Registration Completed. And now we have set up communications with Wi-Fi, and our system is running. We're on the main home screen here. And And once it loads all the data, we should see if there's any fault or warning codes with the system. Additionally, if there are any fault or warning codes where the LEDs are here, we should see a red LED. And once we put the face cover back on, you can see all the indicators that are there. Perfect. So it looks like we are reading the LG batteries here, which means our communication is set up properly. Battery 1 is at 30% state of charge, and battery 2 is at 21% state of charge, so I'll need to get those charged up. But outside of that, that is the overall quick commissioning guide for the Growatt 11.4 inverter. With the system commissioned and everything's up and running, we're going to go ahead and put the face covers back on and lock up the rest of the system.
Now that we have our system installed and commissioned, we're ready to put it to work. We're going to do some load testing today. Now, some of your inverters may use a different app instead of ShineTools. You may have a sticker on the side that asks you to use the Shiner app, so we're going to show you a little bit of that today. It looks like this white square with the green G instead of the ShineTools app that we've been using. So we're going to go ahead and go into that. And you can see it asks you to turn on Bluetooth. So you'll need to make sure your Bluetooth is on. We'll make sure that it is on in this app. Instead of using Wi-Fi as the other one did, this will search for our Bluetooth device. It has found our device. It may ask you to put in the CC number, and that will be on the side of your inverter on the sticker underneath data logger. We did not have to put that in because we have already put that in. You may need to go to the top right where it says Quick Config, as you did in the other app, and put in some of those things that you did in ShineTools and configure the grid setting. And enable your smart meter and do some of the other things as you did in ShineTools as well. Right now, it is not reading any of our prefigured settings because we don't actually have our inverter on. So we need to turn on our grid to give our inverter power so that we can show you all of the settings that would automatically be read by our app. We'll go ahead and give our inverter power. We see our loads are coming on because we have already enabled the pass-through. Right now we just have our light on. We haven't turned on any of our inductive loads yet. We have an air fryer, heat gun, and a heater. Right now we just have our light to show you we do have power. Okay, we have found our device. We're going to put in the CC number here. It's needing us to update, so it's uploading firmware. So now we can see that we're connected. It says our Wi-Fi is connected. If we had 4G, it would be activated. Our cloud service would be activated. We'll go to Quick Config, and we can see that our grid profile settings are there. Our smart meter is there. All the settings that we set up in our ShineTools. Those are all there. Our EMS settings are there. We have our battery backup activated. Our solar backup is activated. Our battery type. It looks like our batteries are not being read, probably because they're in standby, so let's make sure that they are on. So we'll go ahead and select LG and confirm that, and we'll save. We can see our version information, our network information, our operation information, our batteries, their state of charge. We can see that they are currently charging and the watts that they're charging at. We can see that our meter is online, and we can see if we have any alerts, faults, or warnings, and we can see any history. If we go to the network tab, we can see what our network information is. We can look at analysis, and we can see a neat animated graphic of where our energy is coming from and where it's going, and we have different click-through information there. We can see diagnosis. There's a neat IV PV curve. If you have PV connected there, you can see how much information, how much power and voltage that you're getting from your PV. And different information there. If you have any arc fault current interrupters there, you can see that. We'll go back to our settings, and here's a quick list of all of your settings. If you wanted to set up anything for time of use, you could do that here. If you wanted to set up your on-grid discharging, stop SOC or off-grid charging, we might change that here to say stop discharging our batteries at 20% and save that there. You could change that there. So we'll say save. Okay, let's go ahead and start our load test. We are on grid now. We can see that in our batteries. All right, so we're looking at our battery power right now, our main page. We're going to go ahead and turn on our loads while it's on grid and see how much of a load we can pull. So currently it appears as if we're pulling 3,565 watts from the grid and sending some to our batteries and sending about 3,000 watts to our load. What we're going to do is we're going to cut off all grid power, and we're going to watch our light and see what the cutover time is. Okay, we are actually pulling over 5,000 watts, 5,275 watts from the grid. 4,700 watts, a little more than 4,700 watts are going to our loads, and we have about 560 watts going to charge our batteries. So we're going to cut off our power from our grid and pull all of the power from our batteries. We're going to look at the light to see what our cutover time is, switch over, and see if our air fryer turns off or if it keeps going. The heat is still on, heat gun is still on, light switched over, and our air fryer is still going. And our app shows that we are sending about 4,797 watts from our batteries to power our loads. And we showed a white light on our batteries showing that we're using both of our batteries simultaneously to power our loads. Now, if our grid comes back on, life continues. It takes a few seconds for our batteries to switch back over, but they will begin charging again, and we'll know that when a green light kicks back on beside the power button. We hope this installation and commissioning video has helped you learn how you can possibly do your own. And if you'd like to learn more about this Growatt LG bundle, you can find it on our website at signaturesolar.com.
Also, if you'd like to learn more about the solar industry or how to install some of the products that we carry, you can find that on our website under Programs and Training and Events, where you can register for some of our in-house training courses.
I'm Kelly.
And I'm Alex.
And we're empowering you to own your own power.